Let's think about the Earth going around the Sun. That's the Sun. Okay, looks a bit like my little yellow board. And say that's the Earth. That's the Earth. And the Earth goes round the Sun. Now, this path of the Earth, that the Earth traces out, as it goes round the Sun, is called an orbit. So that's the orbit of the Earth, and to a very good accuracy, the Earth keeps going round and round exactly the same path year after year. And this path is almost circular. It is slightly different from a circle, but it is almost circular. So for our exercise now, I'm just going to assume that it's a perfect circle, and we'll see that it would be quite accurate. Right, what I want to do is this. Now we have learned about the Newton's law of gravitation, that the gravitational force between two objects is given by gmm over r squared. And we have also learned about centripetal force, when an object goes round in a circle, we need a force pointing towards the center. If it goes round at a constant speed, we need a force pointing towards the center to keep it in the circular motion, and that's called the centripetal force, and it is given by this formula, by the formula either in this form, m omega squared r, where omega is the angular velocity, or it can also be written in one or two other forms. I'll just write down this other form as well, v squared over r. So we can use either one. Okay, r here refers to the distance from the circle to the center of the circle, and in this case, my m here, capital M, is the mass of the Sun, for example, and little m is the mass of the Earth. Now, let me think about this circular motion of the Earth. So the Earth goes around the Sun in a circle. Goes around the Sun in a circle. Now, as we have learned, in order for an object to go around in a circle at a constant speed, okay, there must be a force pulling it towards the center of the circle. Since the Earth is going around the Sun at a constant speed, there must be such a force. But where does this force come from? So to find out, what we would do is to take a look at what's around the Earth. Well, the closest thing is probably the Moon. Okay, there's a moon going around the Earth. Now the next closest thing might be the Sun. It should be the Sun. No, there are other planets as well, right? But the most massive thing in the neighborhood would be the Sun. So therefore, if you're talking about forces, we would expect that gravitational force, force of attraction between masses, are the only type of forces around. And as I mentioned, there are other planets like Mars on one side, Mercury, Venus on the other side, but they're all a lot less smaller and less massive. a lot less massive than the Sun. So that makes the Sun the most likely source of gravitational force that acts on Earth. And in fact, it's most likely to be the main force acting on Earth. So if you're looking for a force that can cause a circular motion around the Sun is the most likely place to look. And obviously, if the Earth is going around the Sun with the Sun as the center, then the Sun is the most likely origin of this gravitational force. So what we are going to do is that we are going to, if you like, make a hypothesis that the Sun provides that the gravitational force from the Sun provides the centripetal force that causes the Earth to go around the Sun. Okay, let's say that arrow then is the velocity of the Earth. Let me just write that down. So we must not think that this arrow shows a force. So there's no force in this direction. There's only one force towards the Sun. So we are going to make this guess, if you like, that the centripetal force comes from the gravitational force. Now that I've written down the formula for the gravitational force and the centripetal force, what I can do is this, right? Once I start making this guess, I can say, right, that means that these two must be equal. These two must be equal. So what I'm going to do is this. I'm going to try and use this guess, this idea, right, to predict something. To predict something. Now, I am going to predict the time for the Earth to go one round around the Sun. Okay, so I'm going to write down this question. Okay, how long does it take? Does it take the Earth to go round the Sun? Now we already know the answer. Actually, we know that the answer is 1 year. Exactly. But what I'm going to do is this. I'm going to pretend that I don't know the answer, and I'm going to use these two equations. Alright, use our knowledge, our knowledge of physics, use our knowledge that the centripetal force is given by this formula and gravitational force by this formula. Okay, in a way, if I can get the correct answer using these two formulas, then that also show that Newton's law of gravitation is correct, or is quite likely to be correct. Okay, so it's like this would also be a test of Newton's law of gravitation, which is something that came from Newton himself, I think. Okay, right, let's get started then. Now, in order to use these equations, I'll probably need values for the masses of the Sun, the Earth, and the radius. So I'm going to assume that it's possible to get all this, which I've actually done from Google and Wikipedia. So we'll write this down in a moment. But for now, let's look at the equation and see how we can use this to find the answer.